I decide solving the equation by completing the square.
Or by factoring. We try first to factor. If it doesn't work, completing the square. Sometimes we can look at the question and go, both methods are going to work. Completing the square always works. Factoring doesn't always work.
It only works when I get this.
And so sometimes we analyze a question and decide right away, right, whether I want to do one or the other. But that comes with practice. And we're going to learn a third technique to do them as well, which has a formula. So that's going to be the next part. Person stands on a cliff that's 55 meters tall. I'm going to draw this as a picture. Here's my cliff. This is 55 meters. Here's my person. Ooh, that's not a very good stick person. They have no body. Oh well. Throws a stone up in the air, comes down and hits, oh, there's water down here. Hits the water a few seconds later. Okay? And they give us the formula. H equals 55 plus 30t minus 5t squared. When will it hit the water? Okay? And how is this related to what we've been doing so far? So first of all, it's nice that they gave us the equation. First of all, I want you to notice something. When t is 0, what's the height? 55. Does that make sense that at time 0, I guess the stone is right on it. He's maybe throwing it with his foot. Otherwise he'd have to like lie down to throw it exactly from 55 meters. But the height is 55 meters at time 0 because the stone is here. What do we want to find? We want to find the time. So we're going to be solving for t when it hits the water. When it hits the water tells us something about this equation. What do we know when it hits the water?
Height is 0.
The height is 0 when it hits the water. Does that make sense? If it's 55 meters up, when it hits the water, it's right here at 0. And so we read this question, and all of that reading is just for us to plug this in. And it's a quadratic equation, and we can either factor or complete the square. First of all, whether I'm factoring or completing the square, I like to have whatever is in front of the t squared to be positive. So I'm going to just take everything and move it to the other side. And I'm going to write the t squared first, and then I move the 30t over, move the 55 over, equals 0. Whether you factor or you use the or you use completing the square, solving by square rooting, do you see that there's a common factor of 5? In an equation, you can either factor that 5 out, or you could have divided everything by 5 and just made it go away. Because if you divide the other side by 5, 0 divided by 5 would be 0. So let's say I divide everything by 5 now. I get this to be equal to 0. So the question asked earlier, should I use factoring or should I use the completing the square method? I always like to check factoring first. The 11 makes it have to be 11 and 1. It doesn't feel like it's going to ever be 6. So then I set myself up. Move the 11 over. I set myself up because I want to get something squared. Okay? Now there was that minus 6 is our only hint. Some of you might have been like, oh, it has to be negative because the 6 is negative. And some of you might have figured out the shortcut to see it right away. But you have to imagine, if I square this out, if I had t minus something and t minus something. The outside and the inside have to give me 6. And this number has to be the same. Any ideas? 3. Right, does that make sense? If a 3 is here and a 3 is here, my outside is minus 3, my inside is minus 3. That will give me minus 6. If I have a minus 3 there would have been a number here if I multiplied it out. Minus 3 times minus 3 would give me a plus 9. So I have to have that plus 9 there, which means in order to keep my equation equal, if I add 9 to one side, I have to add 9 to the other side, which makes this 20. And now I can square root both sides. Does the textbook have this at the answer at the bottom? No? Oh, it has it in seconds. So now, right, because this is a calculator question because it says to the nearest tenth. So we're going to go to our calculator, and I'm going to do it, I'll do it on the screen here. See how they have plus or minus? So I take out my calculator, and I'll do 3 plus the square root of 20. That would be one answer. And I'll do 3 minus the square root of 20. That would be the other answer. 7.47, how many decimals did they want? Nearest tenth, so 7.5 and negative 1.5. $7.5. Now it's a word problem. If this was just an algebra problem, both of those answers would be right. But because it's a word problem, one of those answers is problematic. Which answer is problematic?
Would be the negative.
The negative one is problematic. Because if we think about this, it's like, I'm on top of a cliff, I throw the stone off, and it hits the water 1.5 seconds before I threw it. That's my answer. Obvious that would happen. It doesn't make sense. You can't throw a stone and 1.5 seconds before you throw it, it hits the water. So the only one that makes sense is the 7.5. So in word problems, not only do we get our answers algebraically, but we also have to think, do they make sense with the context of the question? And there's a lot of good physics stuff going on in this question. Are any of you taking physics right now? Yes. Okay. So, first of all, some physics stuff. This question, if you look at this number in this equation, that is actually the initial speed of this rock. 30, in this case, meters per second. That's pretty fast. And if you look at this number here, the -5, and double it, that should be gravity. Is it close? Is this an accurate kind of question? What's gravity?
9.8.
-9.8. And what did they use in the question?
10.
-10. Do you know why they used -10? To make your math easier.
Rounded up.
If they used -4.9 and actually was more accurate, our math would be more painful. So they were trying to be a little bit nice, but still create a nice question for you. Okay, here we go. We're going to pause our video.